show me on your hands. Did you go to the bathroom? Did you go to the bathroom? You can go now, or unless you want to wait till after this. I saw a lot of 5s and 2 and 3. So we'll do those 3 and then talk about new stuff. With number 2, this was on your answer sheet. I forgot to put this up, so I'm just going to draw a rough draft of this graph. There we go. It may not be accurate. But on your graph, you would have started at 1. And then you could go in 2 directions, up 2 and left 3. And do that and fill up your graph. And then down 2 and right 3. Something like that. Again, this is a rough graph of the graph. Make sure you connect all of your points, draw a straight line or attempt to, and then make sure you have arrows at the ends. Questions on that? Number 3, solve the following equation for x. We want to get x by itself, so get rid of the y term by adding it to the other side. And then our last step would be to get x by itself, divide everything by 2. So that everything simplifies. X equals 4 plus 2y. Or if you put 2y plus 4, that was also fine. Yes.
I got x equals -2y minus 4.
So we move this over by adding, so it shouldn't still be negative. So we added here. So everything should be positive. Other questions on that one? Yeah.
I did it like ax minus by equals c, so like I did like 2x equals 8 divided by 2, so that 4. Is that okay?
So in this one, we're not looking for x-intercept. If we were looking for the x-intercept, we would put 0 in for y and then solve it that way. But because it just asks us to solve for x, we just want to get an equation that has an x equals. Yeah.
I got x equals 8 plus 4y over 2.
So you need to simplify it. Divide it separately and simplify it. Alright, and then number 5. This one, you have a fraction that equals another fraction, so you're going to cross multiply. The 3 to everything there, and then the 2 to everything there. So that would look like 2 times x minus 3 equals 3 times x plus 1. Doesn't matter which side you put that on. You just have to have both. Then you can distribute. 2x minus 6 equals 3x plus 3. And then you can start to move things. So it doesn't matter what you started with. Let's say I got rid of 2x by subtracting. And at the same time, I subtracted 3 to the other side. Those cancel, leaving negative 9 equals x. Questions on that one? So make sure your work and answers are on the answer sheet, shortcut answer sheet. If you need more space, grab another piece of paper, staple that too. I want you to look at your course calendar. So of course the Unit 2B, the parallel perpendicular lines, and the word problems was on marking period 2. This will also be on marking period 2. So we're going to start our new unit today on systems. So you may remember something about that, but we're going to go back over those things. Notice which assignments are informative and formative. Still practice them, just disregarding whichever type it is, because they are good practice. If you have not been utilizing my office hours, Miss Shepherd's office hours, Math Honor Society's hours, please do so. We all want you to be successful, so please come get help whenever you need help or ask in class. Because of all the breaks, we won't test this until like before Thanksgiving break, and then flex around that time. Questions on any of that? So even though we have all the breaks in between, I still want you practicing. So take your notes, practice questions that we didn't do to keep that stuff fresh in your mind. Alright, so today we're going to start with the first part of systems, which is graphing systems of equations by graphing. So everyone should have these notes. And any iPads and computers, put away. Could you minimize that timer? Yeah. Thank you. Alright, so on the first page, we're talking about, or it asks, determine if the given values are a solution to the system of equations or not. So one, in general, a system of equations is more than one. So if you move on to algebra 2, you'll deal with 3. This class will just deal with 2. But if we were to determine, let's say I got this as a solution, how could I figure out, is this my solution or not? Algebraic. Think about when we got solutions for just regular equations. What do we do to test that? Remember that? So one thing I could do, if I got a solution at the end, is put it back in. See, does it work? So we're going to do the same thing. So with this, I'm going to put the 3 in for all the x's and the 2 in for all the y's. So let's do that. So we'll do this one at a time. Let's do the first one first. And we're going to see, does this make this true? Is it a true statement? So if I put 3 in here and I multiply this part, this gives me -1. Does -1 plus 3 equal 2? Yes. So I can say that's a true statement. But in order for this to be a solution to this system, it has to work for both. If it doesn't work for both, it's not a solution. So let's test the other one. So same thing. Put 2 in for y and 3 in for x. And then if I were to multiply this, I get 6. Does 6 minus 4 give us 2? Yes. So this is a true statement for both, so I can say this one is the solution for this. So let's say I solved this and I got this answer, and I went back and I just checked it. Yes, this is my actual solution. I didn't make any mistakes. That is my answer. Questions on that? Angel, Captain. Okay, we're going to do number 3. Now, 3 is not in the same format. We don't have to change it. We can do exactly what we just did. Put 4 in for the x's and put -2 in for the y's. So let's do the first one. And we're going to see, does this equal 12? Well, this is going to be a -16. Does -2 minus 16 equal 12? No. It's going to be -18. So because it already doesn't work for one of them, it's not going to work for the other. Anderson.
I thought the 4 was supposed to be.
Did I do that backwards? Yes, I did it. Okay. Alright. So now, does 4 plus 8 equal 12? Yes. My apologies. For my friend. Okay. Now let's try the other one. There goes in for us. There. So on this one, you're going to multiply both things. So this would be 12 plus 4. Does 12 plus 4 equal -4? No. Because that would be 16. So because that one did not equal, this is not the solution. That means if we were solving this, something went wrong and I got this answer, but it's not the correct one. I want you to try 2 and 4, and then we'll finish 2 and 4 after lunch. So start on that now, and then we'll. For the first one, did we find that was or was not a solution? Was not. Did anyone need to see that one? What about number 4? Did we get to that one? Did anyone find that was or was not a solution? Okay, so we got 2 different things. So let's test that one.
Oh wait, no, I got that it was.
That it was, okay. Everyone else got that it was? No, so let's slow it down. Okay, so this will be 5 times -2 minus 2 times -1 equals -8. This would give us a -10. This would give us a +2. And then -10 plus 2 is -8. So that is true. And then if we do the second one, 3 times -2 plus 2 times -1 equals -8. This would be a -6. This would be a -2. And this does equal -8. So this should have worked. This was a solution. Number 2 was not. You got, but it wasn't. Alright, so as as we start getting into this, that will always be something you can go back and do. Put the solution in, see, is this actually my solution or not? Now we're going to talk about how we actually find the solution. So with these, we're going to state the equation and the solution, which is where they cross. So let's start with, where do they cross? What is the solution for number 5? Yes. -2, -1. You're going to write that as an ordered pair. They cross at that point. That is our solution. Now we're just going to find the equations of the other two of the lines. I'm going to highlight them just so you see them together. So for this one, I see that it crosses at -4, so that's going to be my y-intercept. And then I need to find another point that goes through the grid lines exactly. I could look at the solution and count that slope. So going up 4 over 2, up 3 over 2. And then if I keep doing that, up 1, 2, 3 over 2, I should end up at another point. So the equation of my green line that I highlighted is, let's actually do that in green. Y equals -2 over 3x minus 4. So going back to our graphs, going back to writing equations from graphs, all of that is connecting here. Yes? You're thinking for slope? Yeah. Oh, because I wrote it backwards. Thank you. -3 over 2. Okay. Thank you. Because I went up 3 over 2, but I wrote it wrong originally. Because I wrote it, I just fixed it. It was 2 over 3, but it should be 3 over 2. Right. Yeah, I just fixed it, but it was this. And that was wrong. If you wrote that, then you're good. Okay. Alright, the other one, I'll highlight that one. That one crosses at -2. So if we're counting that slope and I look at the solution point, I'm going up 1, left 2. So up 1, left 2, or down 1, right 2. So that slope would be -1/2 and goes through 2. I said it out loud so that I wrote it correctly this time. You got it. Okay. Right. Questions on that part? So that's just being able to recognize, write the equations, and find that. We'll do one more of these, and then we'll move on to the actual how do we actually graph our systems. So let's do number 6. What is the solution of that one? Where do those two end? -1, -1. So then if I do this line first, we'll call that pink, purple, whatever. This line crosses the y-axis at what point? -4. And then if I'm counting that slope, I'm going up 1, 2, 3 over 1. If I keep doing that, up 1, 2, 3 over 1, 1, 2, 3 over 1. So that would be a -3 slope with a y-intercept of -4. And then the other one And that goes through the y axis at what value?
7. Bigger.
Where does that cross the y axis?
3.
And if I'm going to this point, I'm going down 1, 2, 3, 4 to the left 1. That's going to be a positive 4 over 1. So that equation would be y equals 4x plus 3. Okay, questions on those? Look at the next page. So there's a little picture on top, we'll talk about that, and then we'll give you the actual graphic keys. I don't have that picture up here. But on your notes, you'll see it says types of solutions. These graphs are a little small, so we're actually going to go to this page and talk about those types of solutions. So I told you what the systems of equations was, but now you'll see the actual definition. So systems of equations are two or more equations with the same variables. And then this is talking about the solution. So graphically, it's the point where the xy, that point where they cross, where they intersect. Algebraically, when we did this, it's the point that makes both equations true. So you can look and find your solution to a set of systems, algebraically or graphically. For me, you'll just graph them and find where they cross, if they cross. And then there are 3 types. I want you to draw this, do a rough graph of this. So the intersecting lines are the examples we were just doing. They cross. And that's that one solution. So if they cross, if you have 2 lines that cross, you'll get one solution, and that's going to give you some ordered pair x, y. You could also have parallel lines, which we know from the last unit that they never cross. So if we're looking for something that crosses, if they never cross, you're going to have no solution. Well, that's what I don't do that. Anyway. And then you might have something where they graph on top of each other. They end up being the exact same line. So that means they cross everywhere on that line. So that would be infinitely many solutions. So we're going to graph a couple of these, and then you'll have time to practice, / if you want to work on retake work, missing tests after we go through a couple. Okay. So looking at, we're going to start with this example down here. I forgot it had so the steps, if you want these steps, to solve a system, we're going to rewrite the equations in slope-intercept form if they're not already. we're going to graph the two lines and then identify the solution. Now you could identify the solution from the equations, but you still have to graph the lines. Guys, I need you to close your computers. Thank you. So looking at example 1, just looking at the equations before we even graph them, are these two lines parallel? They don't have the same slope. Are they the exact same line? No. So I know already these are not going to be parallel lines. These are not going to be the same line. So these are going to be something that crosses and gives me a solution. So let's graph those two. If you want to grab rulers, you can grab those. I'm going to color code just to make lives easier. If you also want to do that, there are color pencils, or you can grab two different utensils. Pen, pencil, color pencil, whatever, highlighter. And then I'm going to graph one of them, starting at the y-intercept, so -8. The slope of that one is 1, so that's a positive 1 over 1. So every time I go up 1 over 1, I'm going to plot another point, and I'm going to fill up my graph with those points. And then go the opposite way, down 1 and left 1. Once you have all of your points, go ahead and make that line, draw a line through it as straight as possible. Make sure you have arrows at the ends, because lines go on forever and ever. Then we're going to graph the other one. This one, the y-intercept is 1, so I'm going to start at +1. My slope is a -2 over 1. So I'm going to go up 2 to the left 1 as many times as possible. And then down 2 to the right 1 as many times as possible. And when you do that, you'll see where they cross. Go ahead and make your line as straight as possible. Draw arrows at the ends. What is that solution? Where did those come from? 3, -5. We just solved a system of equations by graphing. Do you have any questions? Yes. Yes. Okay, we're going to do an example where maybe it's not in slope-intercept form. So let's go to the next page. Like number 3. And then we'll do 4, and then you'll have time to practice. Okay, so both of these are not in slope-intercept form. Actually, let's do 5, sorry. Let's do 5 instead of 4, just because it'll be similar. This one is not in slope-intercept form. This one is in equation. It's in the equation format. So I could graph that one right away, or I could solve this first. I'll do that first. Solve this first. So we gotta get rid of x, subtract it to the other side. And then get y by itself by dividing everything by 3. So this is really -1, so this is -1/3 x minus 5. And then we can go ahead and graph that one. Starting at -5. And then slope is -1/3, so go up 1, left 3, as many times as possible. Once you have all of your points, go ahead and make your line. Now this other one is thinking back to our foy bucks. Is this going to be a horizontal or a vertical line? Horizontal. So at -7, so this was -5 right here. I'm going to draw a straight line across. Where would that solution be? Where do those two lines cross? Yes, because whatever the y value is was going to be 6. Do we have any questions so far? Okay. In number 4, let's solve this first one, and then we'll look at it and then graph it, and then you guys will practice. So to start solving this one, I would subtract x first. And divide everything by 2. So this is -1x, so this would be -1/2 x plus 2. Before we graph this, what do we notice about the equations? Yes, and? So, if they had the same slope and different y-intercepts, they would be parallel, but do they? No, they're exactly the same. This is going to tell us this is going to be infinitely many solutions. So with this, I want you to draw one of the lines, and then I'll show you a couple different options of how you can show this second. So because they're the same, they're overlapping. So start at +2. Slope is -1/2, so up 1, left 2, as many times as possible. Down 1, right 2, as many times as possible. graph that line. And then for your second line, you can either draw an extra set of arrows, which I'll show you in a second, or you can grab like a highlighter or a color pencil and just draw right over the top of it. So the highlighter would just look something like this. So I can see Pat was off, but if it was on it, I could see that those were two different lines. Let's just get rid of that. Okay. Or you could just draw an extra set of arrows. So after the arrow you already have, just come out and draw another one. Like there was another line. So either or. You just have to show that there were two lines there. Okay, questions there? For the parallel lines, you would have two lines. Okay, you guys have enough math on this. That is due today. I want you to try this. In the side link, you can access this. If you are missing a test or want to do retake work, you could do that instead. But we're working on one of those three things.